Information is everywhere. In particular, data is everywhere. You make decisions because of it. It helps inform your life. What is it? Data is plural, and it means information, facts, or numbers that describe something. You have to realize that's super general, and it really can be any piece of information. We're going to be particularly focused on data that takes the form of numbers. Here is a whole bunch of data arranged in a table, and what this is top categories of food consumed by Americans, and it's important to note that this is in pounds, and it's per person per year. So we have 1970, 1975, 1980, 1985, and we have dairy, vegetables, and fruit. It's kind of interesting to think about this data. But that's what we're going to do. We're going to try to draw some conclusions. We're going to try to notice some patterns. But tables are really helpful for organizing data because it makes it very easy to look up specific data points. I could ask you, how many pounds of vegetables did every American eat on average in 1990? And you could immediately go to 1990 and go down to vegetables and get to 382.8. A question you could ask is, in which 5-year period did the total consumption per person of dairy, fruit, vegetables increase the most? Increase the most. When was there a decrease in total consumption? So it's important to realize that we're now looking at total consumption, not just dairy or just fruits or just vegetables. So in order to answer this question, we're really going to add 2 more rows to this table. The first row we're going to add is the total pounds consumed. So what's been done here is these numbers have been added together to get the total. Similarly right there and right there, all the way through. And then what was done is the net change, the total change in each 5-year period was calculated. So this total right here, 1,128.2, that was subtracted from that was 1,136.9. So the change from 1970 to 1975 was negative 8.7. Overall, Americans consumed 8.7 less pounds of food in the year. And then the same thing was done for these two numbers. 1,128.2 was subtracted from 1,142, meaning Americans ate 13.8 pounds more. So you fill in the rest of these boxes, and then you can answer the questions that were asked. So let's go back and see what it asked. It said, in which 5-year period did the total consumption per person, total consumption, increase the most? So which number is largest here in the net change row? And that's 79.5. It looks like it increased the most from 1980 to 1985. When was there a decrease in total consumption? It looks like there was a decrease right here. So from 1970 to 1975, there was a decrease in total consumption. It's also important to note that we don't know what the net change was there because they get the change from 1965 to 1970. We need the data from 1965, but we don't have that data as part of this chart. You might also arrange data in a bar graph like this. So this gives you consumption of dairy, fruit, and vegetables, the same data as before, in each year. So when you look at data, one thing you're naturally drawn to do is make conclusions. So it kind of looks like there's a big trend going up. It looks like it's going to continue, maybe make some predictions, maybe make some models. But let's look at question A, which says, explain why the graph could be misleading. So when you look at this, there's no error in the data. It could be misleading because there could just be a mistake. Something could be left off or reordered. But the key thing to realize here is this little break here. Take a look. It jumps from 0 all the way up to 1,125. What that ends up doing is dramatically kind of cutting off these bars. These bars extend really far down. Each of these bars goes way down. Meaning, what looks like a really steep hill, this looks steep, is not really that steep. What should it actually look like? Here's what the bar graph would actually look like if you included all of these numbers on the y-axis, the consumption axis. So now you notice that the increase doesn't look quite as dramatic. There's definitely still an increase, but it's not as dramatic. Sometimes this is a useful tool. This isn't just cheating on the part of the people showing you this data, but it can kind of be used to manipulate what people's visual impression. This looks like there's a huge increase right here, and here it doesn't look like it's very, this is pretty small. But again, these are relative terms. meaning what is small to one person is big to another, and what is big to one person is small to another. But it's just important to be able to read your data correctly. And in this case, in this bar graph, the fact that it jumps from 0 to 1,125 is really important to realize. Here's another set of data. From 1983 to 1996, the average cost in millions of dollars of making a movie is given in this table. So you can take a look at it and make some general observations. It looks like it's going up, but we want to make some specific conclusions. So we're going to do that by making a line graph. We're going to plot these points, and then we're going to connect them. And then we're going to use that graph to figure out in which 3 years did the average cost decrease from the prior year, and which year showed the greatest decrease. So let's see what that graph looks like. Here it is. So all we've done is plotted each point and then connected each point with a straight line. If we had more points in between, it might not be straight in between, but this is a good approximation. So in which 3 years did the average cost decrease from the previous year? Decrease means it's going to go down from the previous year. So it looks like here is at the end of a decrease, here is at the end of a decrease, and here. So the answer for B would be 1988, 1991, and 1996. And then it's going to ask which year showed the greatest decrease, Now you could look at this graph and try to figure out where did it go from one year to the next, did it go down the most? And you can do that visually in some cases, and it looks like right here it went down the most because the graph went from here to here, and it looks like that distance is greater than that distance or that distance. It looks like the biggest gap is right there. How could we actually figure that out? We could look at the data in the table. What we'd want to do is look at 87 to 88. So right here, it looks like it went down minus 1.9 million. And then from 1990 to 91, looks like it went down 0.7 million. And then from 1995 to 1996, it went down 2.8 million. So we've just verified our visual conclusion with the fact that negative 2.8 is the smallest of the 3 decreases. So please remember a few things. Tables can help you organize lots and lots of data. Bar graphs can also be helpful. And it's important to be a knowledgeable consumer of data. You need to keep in mind things that could be potentially misleading, like that gap between 0 and 1,125. I hope you found this video useful.